Yeah, has 22 years experience in Lean and Six Sigma. And the majority of his experience is using Lean processes as a problem resolution set of tools. So currently he's a defensive satellite operations service matter expert for the U.S. Space Command at Vandenberg Air Force Base, California. Greg, welcome.
Hey, glad to be here. Thank you for having me, Eric.
All right, Greg. Hey, Greg. So that's a lot of words in a title. So maybe you can tell us a little bit as how is Lean related to your job on a day-to-day basis?
Oh, glad to, Eric. As I was listening to the presenters and discuss their different projects that they were going to try and evaluate and the processes they're going to try and solve, I was going through them thinking, wow, I think I do all of them. I have to deal with schedules, creation of effective events, efficiency of how we operate, compliance with requests for service, feedback, as well as inventory control because of what's available, when it's going to be available, and when it's delivered. So I'm doing kind of a little bit of all of those things and trying to provide satellite services and capabilities such as satellite communications, GPS, imaging, satellite pictures that you see on TV right now about natural disasters or fires, things like that. Those are all services and capabilities provided by Space Force. And they all help make your life a little bit easier.
So Craig, as a project manager, do you help put that stuff up into space, or do you help sort of maintain it, or redirect capabilities, or?
What I do is I help coordinate the delivery of those services and capabilities, making sure, helping that the specific service you want provided by the satellite is there when you need it and functioning and ready to go. So it's a combination of availability, the integrity that it's going to work, as well as the robustness of the entire system. I support the coordination of all those things that provide that to people here, the people here on Earth.
Craig, it sort of makes me think a little bit. So Motorola was sort of the originator of the Six Sigma concept, and I remember reading some of the early stories talking about, well, if you've got these headsets or cell phone, they were starting to build out this system, and there are just so many transistors and nodes and things. If one thing goes wrong, right, or 3.4 things out of a million go wrong, we're going to have big problems. And you kind of deal with that on a day-to-day basis. There's a lot of connections and things that have to work in order for that signal to get from one place to another.
That's very true. That's very true. One of the commanders out here at the base once said that for a rocket to launch and go into orbit successfully, literally 1 million things have to work perfectly together. For that rocket to explode and crash and destroy that $1 billion worth of space technology, sometimes one thing just needs to go wrong. It is very, very difficult. Fortunately, it's very much of a team effort built of diverse skills and talents, and everybody trying to work together collaboratively to produce a strong end result.
Yeah. So Greg, can you tell us a little bit about like your Lean journey? Like how do you get to do this sort of stuff in the field that you're in?
Okay, Lean, my Lean journey is a little bit unusual because I have a very diverse background. I spent 10 years in the military and actually doing some things Lean. I just didn't know that's what they were at the time. And until I was getting ready to leave and I got my master's in Lean, and I was like, oh, that's what we did. Okay. But at least I had it would have been so much easier if I'd had these tools and concepts to work with from the start. So that was would have been nice. But so after then I went to private industry, worked on some of the things I had done in the Navy. I'd worked on helicopters. And when I went to private industry, even though I had my lean certification and my lean degree, while I was working on helicopters again in private industry, I was able to consciously apply lean tools to do a massive amount of problem solving. So even though I wasn't assigned to quality control, when I had production issues, I was able to use the tools that you get from lean, process mapping, the value added for some of the steps, looking at using our Ishikawa diagram to figure out where the problem solution might be in order to continue to be successful in delivering the things we were building for the helicopter. After that, then I went back into the Air Force for a while. And then after I retired from the Air Force, I decided to stay local, and I transitioned to doing more of the coordination of satellite support out at Vandenberg. And I still use lean tools to this day to solve these types of coordination, delivery, efficiency problems.
So I want to encourage the students to ask Craig questions. So if you're out there, go ahead and raise your hand, and then we'll call on you. Craig, do you have a current challenge that you're working on, and can you give us a lean perspective maybe on how you might apply some of the things that the students are learning in this class to that challenge?
Gladly. Actually, as you were going through it, discussing the different things of scheduling, of creating things, of being efficient in delivery things, building things, compliance, such as getting people to pay dues. We have that out here. We have to get people, the engineers and technicians who are building these high technology components to comply with the standards, which is not as easy as it looks. And when Megan was describing that startup company, the issues they were having, coordination. So I'm trying to do all of those things right now to make them to fit them together.
Yeah.
So if I'm not quite sure I answered your question, but all the things.
Yeah.
Go ahead. I'm sorry.
Yeah, I was hoping you could sort of tell us maybe a specific sort of challenge that you were having. I know that when we talk offline about some of the things that you're doing some pretty wild stuff, and it's not always about applying the specific tools like the Ishikawa diagram or Pareto chart things, but sometimes it's about just being able to use that sort of systematic thinking.
True.
That we apply in this class. So
okay, well that's okay. But yeah, that is daily what we have to do. If we want to maneuver a satellite, we have to think about all of the collateral effects that will have. Are we moving it to a safe place? There's a lot of debris in space we have to watch out for. When we move it, how are we going to affect the life of the satellite? Because it takes fuel to burn to move that satellite. When we move it, are we going to lose those services that satellite provides, such as your satellite communications? Are you going to lose a TV signal? Are you going to lose a radio signal that's going over that because of the move? Once it gets into, is it going to be damaged by the move? Where are you going to move it to? How long can it stay there? There's all things that just all have, it's a whole systemic aspect that all these different categories, you come together to be able to deliver it. And it's just a multitude of, like you said, you really think it from a systemic perspective. And in the end, are you going to indeed be better off for making this move?
Yeah, really. And so one of the things that when you described that, it was sort of making me think of something like a failure modes and effects analysis, right? And saying, okay, for this particular process or move or thing that we're going to do out in space, what are all the things that could potentially go wrong? How severe could they be? what would their frequency be? Like, how probable are they? And, how can we tell whether they're there? But then there's also maybe other levels about, and what other things could it affect or things like that. So it's a real sort of systematic, we got to go through all these things before we can actually sort of make the process and know that we're not going to have a problem. Because, like you said, you can't really reverse, very well. Right?
That's an excellent description of what the considerations are. And one more I'd like to add in is assumptions versus facts. We have assumptions about how things are going to happen, but we need them to be facts. And so we're always looking at what piece of information, called the essential elements of information, do we need to change that assumption into a fact that it will indeed happen the way we are planning it to do. And then suppose something unplanned happens. We always have to think, what if?
Yeah. So Craig, could you give us an example of either a great lean success or a failure? We learned from both of those. Do you have something you can share with the students? And did we forget to record this?
Nope, we're recording it.
We're recording? Okay.
Okay, well, let me bring it back down to earth and do something that would maybe be more relatable to folks. When I first, my first civilian job, we were building a radar system that could be transported on an airplane. And it had a component of a control unit and a radar antenna. The control unit was basically, think of like a shipping container. We would load it up with equipment racks, avionics, computers, controls, and also control station for a person to sit in. And we were moving forward to building this out. And my manager came to me and said, well, this, the shipping container that we're going to build, you're going to build out, we're going to give it to another program. They have a sooner due date than you do. Okay, what's that going to do to me? Oh, you're going to lose 4 months, and your program's going to be late now. Okay, well, but they kind of left it with me. And but my performance was based on on-time delivery. So I met with the team. We said, okay, how do we deal with this? And we started using some of the lean tools. We did some process mapping. Then we started looking at what could happen with what could we do without this shipping container. We did the 5 whys. Why do we have to have it? Well, the 5 whys were particularly important, because why do we have to have the shipping container? Well, that's where we load our avionics. Why do we have to load it with the avionics? Well, that's the avionics going to a rack. Well, why does a rack have to have the unit? It doesn't. Why not? Well, the rack is self-contained. We just have to build the racks. We just attach them to the walls. So we can build the racks without the shipping containers. And everyone kind of looked at each other and said, yeah, we probably could. And then somebody said that the actual technician who was going to be doing the actual calibration and installation of the avionics said that would actually make his job a lot easier, because then he could be free to walk around to access the different the backs of the avionics equipment. And so we built out the rack, installed the avionics, tested them out. And so instead of waiting 4 months for the shipping container, container to come in, and so when it arrived, we had done all of the work that normally would have taken another 3 months. So we didn't lose all that much time because of my knowledge of some of the lean tools and how we applied them as a team.
Yeah, it's interesting. Sometimes it's just it's about asking those sort of good questions. I think sometimes in lean we sort of talk about like coming at things with a child's mind, saying, okay, well, why, right? And you can come up with some good solutions that way. I want to get at least one student question on here. So let's see if we can get one student sort of pop on with a question. Is there anybody here that can help us out? on its space, you know, there's not a big limit to the number of questions you can handle. What do we got? Now, one of our folks online, anything in the chat?
Nope.
Yeah.
Some brave soul.
Yeah. Okay, so I guess we're gonna have to go till 6 o'clock tonight, you know, on the thing, because we're slowing down here. It's probably gonna back the whole class up until probably 6 or so. Anybody give me, come on, somebody give me a question. There's gotta be somebody out there with,
Hey, real quick, did we cover the Shingle model of waste yet or
Not yet.
no? Okay, so, yeah, what's the largest waste that you see in your work?
okay, so, all right, so we have like a Maverick from in class here. So what's the biggest waste? So you know in Lean, we've got the 7 wastes. What's sort of the biggest waste you see in your field, Greg?
Establish policies. Why do we establish policies? Quite often it's, why do we do things? Well, that's because what the policy says. That's what the rule is. And without looking at the rationale behind it. One of my favorite lessons that comes from Deming is that every 5 years, you should look at the way you do things. And every 10 years, you should probably toss out your rule book and start from scratch, because the conditions which led to those methods and techniques are probably very outdated. And I found that to be probably the single biggest source of waste I've encountered. Just like with the building out the control unit for the radar. Why do we have to wait for the container? Because we do.
It's just the way
Okay.
we do it.
That was just the mindset, and that's just what was set in place.
Yeah.
And there was no real genuine reason for it.
So I see Parker's got his hand up, but before we go to Parker, I see in chat, we've got a question from Bryce. Bryce, you want to go pop on and ask your question?
Yes, I'm just curious, like when you're working with people, like whether it's on rockets or whatever, what kind of processes like do you find to be more difficult to like optimize in that atmosphere? Like, does it have to do with people or like the machines or like what specifically? And like, how do you overcome that obstacle?
It's usually with people, because when you have something physical like a machine or a component, you can see it. And it's kind of easy, and it's easier to focus on the item being the item. Whereas when it's a process of service or a way of thinking, you're really challenging people's beliefs sometimes, and that gets very difficult because no one wants to say, well, I was wrong. And so looking at how, that's number one. The number two, when it's a process of knowledge, it's hard to sometimes physically measure, because thinking is where is it really a creative difficulty, or is it a uniquely difficult challenge, or is it simply the way information flows? And so that, and so trying to express that with a visible metric is often difficult, especially with a design process for engineering, because it's also a fair amount of creativity involved with it, and that's where it can be quite difficult to say, well, I'm creative, I'm making something new, I don't have to be efficient. Well, maybe yes and no. Let's look at what goes into your creative process. Is it getting the information you need? Is it having questions answered? Is it access to a piece of equipment you need to test a theory? Some of those things, oh, okay, we can start to map some of those out. And also and this can be iterative, because since it's creative and a way of doing things, sometimes you're going to have to revisit that process map a couple of times to make sure everything is really covered. Because quite often it's like, oh, I forgot about that. And so one of the most effective tools I've had is when you're trying to, especially a creative process, is try and start at the end and go backwards. And so that I found tends to inspire or help people give that trigger to think, oh yeah, that's right, I forgot, I needed to do that. And so when you're starting at the end, it's easier to go, well, how do you get there? Well, I have to do these things. Whereas when you're going forward, like an easy trip is an easy example. Okay, we're going to go get some gas. Okay, I get in the car, go get gas. Whereas if you go back, how do you get to the gas station? Oh, I have to drive my car. Okay, what do you have to do to drive your car? Oh, I have to go get my keys. Oh, I have to go get my wallet. Oh, I have to go get my my glasses. So you start to get a lot more granularity, and that can be the real key that you may have overlooked by simply starting at the beginning, especially when you're dealing with something, like I said, doesn't have a physical aspect to it.
So it's almost like you're reverse engineering the entire thing to come to a conclusion.
Yeah.
All right, thank you.
Yeah, thank you, Bryce. Parker, you're gonna help us out with the last question here.
Yeah, so talking about Six Sigma specifically, actual Six Sigma status, how attainable is that actually getting to that Six Sigma level? And if it is attainable, do you find that an aerospace company places more emphasis on Six Sigma than, say, like a dog toy company, because higher stakes for an aerospace company, right?
Oh,
So
that's very true. So how attainable is Six Sigma is what your question is?
yeah, pretty much, yeah.
That's difficult. That's really difficult. I sometimes think Six Sigma is a goal we shoot for, but without a lot of measuring and cost, sometimes getting to that real Six Sigma is very difficult. Wow, that's a tough one.
Yeah,
How do we
exactly,
measure-
because it's like it's like a 0.0000197% chance of
Mhm.
having a defect or something, of having something outside of Six Sigma
So
happen, right? That's-
Craig, and Mark, can I take a little shot, and then, Craig, you can sort of correct me or sort of redirect my thinking on this. So I think, when you have those sort of space systems, yeah, it's super critical, and, having like a, super low defect rate or failure rate is super critical. So what we do is we first start out with trying to make the process as good as we can. So building in the quality, making sure that happens, and we can then sort of measure what the defect rate is on sort of the components. But then we also say, okay, if it's still not good enough, we're going to make it redundant, right? And then we're going to say, if it's still not good enough, it's going to be triple redundant. And then if it's still not good enough, we're going to have, 2 people inspect it, or we're going to, so we're adding on all these layers. So the ultimate output, we're getting that failure rate as low as it needs to be. But because our processes aren't perfect or aren't absolutely capable, we have to layer on some of these other techniques to make that happen, which is wasteful and adds additional cost. But if you need that low failure rate, you've got to do those things. That's maybe one of the reasons why it's a space program so expensive, right?
You're not wrong, Eric. You're not wrong at all. But at the same time, we still are trying to make it profitable, because if it's not profitable, it's not sustainable, and we're not going to do it.
Right.
So you're still looking at doing things that can error proof, that can get that incremental improvements. And sometimes you'll find that you can have a better way of doing it. A classic way when you're building For instance, like I'll back out from going with rockets, going to aircraft. One of the ways you make sure there's fewer aircraft mishaps is, again, like is the Kaizen. Okay, when you do your study, you say, well, there were maybe a tool that was missing. Okay, well, well, you can inspect it, and you can inspect the tool shop, you can inspect the aircraft, or you can create a visual system that at the end of the work being done on the aircraft, you can easily look at your wall, and you'll see if the tool's missing, because what they do in maintenance shops is they don't have toolboxes. All the tools are on a pegboard with outlines on them.
Right.
So you try and use very effective visual inspections or things of that nature. So you can either hire, like Eric said, you can either hire 2 extra inspectors, or you can make a visual tool, a visual system to make immediate inspection obvious. Okay, you want 0 missing tools. Okay, then you use that pegboard idea. And they try and do things like that in when you're manufacturing these components as well.
Yeah.
That's just an easy one that I think everybody can get their head around.
Yeah. Well, Craig, we need to wrap it up for today. Parker, thanks for that question. Craig, it's been a pleasure. Thanks for jumping in and volunteering to be our Lean Celebrity Day. But before we go, could you give these students heading out on their own Lean Six Sigma journeys one piece of advice before you go?
I've been thinking about that. Again, I think it's going to be the big one is assumptions versus facts. When I was looking at the project charter that you were building and you were going over before we had the breakouts, is you were looking at what needed to be done, is how you make those assumptions and look at what's driving them. Because a lot of times it's outdated information, and to try and look at how you deconflict the conflicting assumptions with current factual information.
Yeah, I think that is really is key, Craig, and I think we can wrap it up here at this point. And thank you for being here. I'm going to go ahead and switch over to gallery view at this point. And what we want is everybody go ahead and snap on your videos. Give Craig a wave. That's how I always say thank you. You kind of page over Craig, and you kind of see all the people you hopefully impact.